We said earlier that an electron beam, when interacting with a foil, can diffract, which is a wave property. The wavelength lambda of electrons with mass m moving at a velocity v was predicted by Louis de Broglie using a simple relationship. While we won't use this in our course, the wave properties of electrons can be quantitatively predicted. It would be harder to predict the motion of electrons in an atom. One mathematical approach to that was developed by the Austrian physicist Erwin Schrödinger. It models the electrons as a three-dimensional wave surrounding the nucleus. The motion of these waves is described by mathematical functions called wave functions. As with the Bohr model, the moving electrons are characterized by an energy. The relationship between the wave functions and the energy is given by what is now called the Schrödinger equation. Here are a few different wave functions, which are given the symbol psi. I don't know about you, but these look pretty complicated to me. But it is instructive to see that there are some terms that repeat themselves, like e to the negative zr over a0. And some of the functions have sines and cosines in them. If we looked at all of them, we would find that they could be grouped by similar terms, which we will do with quantum numbers. If you recall the Bohr model of the atom, he said that the electrons move along a two-dimensional pathway and each pathway corresponds to a different energy. Unlike the Bohr model of the atom, these functions describe electron motion in 3 dimensions, but each function still has an energy associated with it, given by the Schrödinger equation. While I wouldn't want to be taking the second derivative of any of those functions, the left-hand part of the equation gives the kinetic energy of the electrons, and the right-hand part gives the potential energy, adding together to give the total energy. The potential energy term should look familiar. Remember Coulomb's law? Charge squared over distance? In this equation, E is the charge of the electron, and R is the distance of the electron from the nucleus. Up next, we need to think about how these functions are grouped by quantum number, and then think about the three-dimensional shapes generated by the functions.